is titled A Nodal Amalgamation, a case for reclaiming walkability in Kalbadevi. So the upcoming underground M3 metro line in Mumbai is currently under construction, connecting the western front of the island city. What can this new mode of transport mean to the future of the city? How can it be integrated into the existing fabric? What can it mean to mobility in and around the neighborhood? An extensive and a well-integrated public transport network in a mega metropolis such as Mumbai is the need of the hour. And now when the transport line is being constructed in a dense city like Mumbai, it poses a certain number of determinants which must be factored in and planned well in advance for. The metro station must be imagined as much more than just serving a civic transit function. In order to make our city less dependent on private vehicles, the station node must be well integrated into the existing fabric. A dense and compact neighborhood around the station node, offering a mixed-use development along with immediate connections to other modes of transport, are imperative for the future of public mobility at a neighborhood level. A highly public and sociable station node is imagined to act as a catalyst to allow the public run to grow, not hinder it, and whilst doing so, build a language for a self-sustainable public and walkable redevelopment of a neighborhood. Multimodal connectivity at the station node level with immediate access to vehicular parking, bus stand, taxi stand and a railway station and places with a high public footfall must be within a walkable or a cyclable distance. So the project envisions a mixed-use nodal amalgamation of three broad categories such as a transit station with housing and commerce in close proximity, along with the presence of public spaces facilitating the integration of the three and letting the public realm grow organically. The three main stakeholders for the project would be the government authority, which would be BMC, MMRC, in charge of maintaining the station and the ground plane, the residential tenants of the housing condominiums, the tenants and owners of the commercial and office spaces. The funding for the project would be a joint venture between the government authorities and private developers with a revenue generating model, making it financially viable. The maintenance of the project will be borne by the three stakeholders with a sizable portion of the revenue coming from the rented community and commercial spaces in the complex. As mentioned earlier, the determinants which decisively affect the functioning of a station node are highlighted in the yellow column and the subsequent spatial manifestations of the same are highlighted in the mint green column. So, two metro stations are being introduced in the dense fabric of Kalbadevi and Girgaon respectively. For the same, over 18 buildings were demolished in the precinct to make way for the underground metro stations. The existing land use map shows the metro route lying in a mixed-use area with the Gymkhana, the cemetery to the left, and the market area to the right. The area sees a very high footfall through the day owing to its extensive market network attracting people from the city and beyond. In the map to the right, the buildings marked in teal blue have been raised to the ground for the metro, including Chira Bazaar, the Chira Bazaar fish market, which lies at a distance of roughly 300 meters or a 5-minute walk from the Marine Lines railway station. The 3D bird's eye view shows the location of the metro station with respect to its surroundings, such as the railway station, Marine Drive, Girgaon metro station, and the market area. The metro route transit study diagrams show a dearth of open spaces in the area, a medium to high pedestrian traffic in the close-knit, densely populated area of Kalbadevi, a medium to high vehicular traffic owing to the high density and narrow roads. I mapped the street front building use on the transect along with roads leading to the railway station and the markets, showing a highly mixed-use ground plane. Interestingly, Kalbadevi is home to a very high number of cessed buildings which are slowly but rampantly being redeveloped into high-rise gated buildings posing a serious threat to the sociability and strong community sense of the fabric. So the site fabric study shows how the street corners are public hotspots with restaurants, eateries, almost always lined with food stalls and hawkers. Another feature that stood out to me was the numerous wadis in the neighborhood. They tucked behind the main street, opening into a large communal space with housing buildings around it. A lot of the daily lives of the residents plays out in these communal spaces. These wadis have multiple entry points, thus creating an informal pedestrian, like a shorter pedestrian network in addition to the main streets. These are a couple of photos from site showing entry points into wadis, the communal spaces, and on the other hand, the recent unsustainable market-driven redevelopment to replace the fabric, threatening to replace the fabric. The site Plots lie on either sides of the JSS road, totaling up to about 9,000 square meters. Further up north along the same road is the Girgaon metro station. This road connects the site to the railway station, and this road connects the site to the market area. The metro station is currently under development. Thus, the design retains the access points of the underground metro station, reimagining the built environment on and above the ground. Site forces and derived strategies. So, the first was to retain the existing trees on site. Second was building, which must be set back from the street edge to allow informal activities to spill out onto the street. Third was to relieve the street corners for pause and interaction. Fourth was to respond to built context in scale and height. The following slides show a couple of design strategies and intent to start off my design process. A porous ground plane allowing a free flow of movement on the ground plane. The second is where to break down the building down, breaking the building down into blocks and courtyards for better connectivity through the building and ratio of built mass to open space. The third was to the public and commercial programs lining the street edge with an arcade, providing a continuous covered pathway, also helping in tying the elevation together. A schematic section through the ground plane showing the street edge with vehicular lanes, a dedicated cycle path, an extended footpath for public activities and interactions to organically grow, a covered walkway and street front shops. The vertical stacking of programs of catering to transport on the ground plane and commerce and housing on top. So hence, with varying degrees of privacy and access to different users of the building complex in mind, separate exclusive service cores leading to the housing floors on the top floors and commerce in the middle floors, I wanted to then play around with the integration and interaction of different programs in the building. I further wanted to explore the possibility of creating an additional public interface on the ground. The scenario 1 shows street front shops of buildings facing a public ground plane. Second shows a skywalk running over the ground plane as a solely functional civic structure detached from the adjacent building. Scenario 3 shows a skywalk being the extension of the building, thus creating an additional public interface high above the ground, devoid of vehicles. The fourth is when the skywalk connects to future development projects, thus overlaying an additional public route over the existing ground network. Following is the massing evolution diagram. So this is the empty site with the surrounding context. This is the extrusion of the footprint of the site. Retaining the existing trees on site. Defining the masses and the courtyards. Setting the building back from the street edge, plot edges and relieving the street corner. Raising the building to make the ground plane porous and more accessible. Adjusting volumes with respect to the context. Buildings along the edges respond to the heights of the context buildings, and the height of the building in the center is raised like a mound. Connecting blocks via bridges and walkways above the ground and amongst the blocks. Here is the overview of the program list for the building complex. There are a couple of existing programs on site which have to be rehabilitated, which being housing and commercial establishments, a BMC school and the Chira Bazaar fish market, plus the proposed programs relating to the metro station and other transit modes, public programs such as an information center, library, co-working spaces, seminar and community halls and public toilets, and also importantly space for informal and unorganized public activities to establish a network and grow and in no way hinder that, helping to retain the communal and public fabric of the site. This is the program axonometric diagram, which shows the public and transit related functions on the ground plane, housing and commerce on top, and the education block tucked off the main street. So there are 7 blocks with connecting courtyards accessible from the street. The JSS road goes through the site one way, heading north. There's a 7 to 10 meter setback on the street. The diagrams to the right of the screen show the program spaces and the circulation space on each floor plate to varying degrees of access, which would be public, private residential, private commercial, and for the school. This is a zoom in of blocks C and D on the main street. The ground plane heavily caters to the public movement in and out of the metro station, with other modes of transport on the street side, such as a cycle path, cycle parking, bus stand, and taxi stands. The street corners and a large building setback from the street allow free flow of movement in and out of the metro station access points. The fish market runs across 3 floors in Block D with the access for the same on the ground plane. Private residential service cores and private commercial service cores are accessed from the ground plane, exclusive to its users. Public elevators and escalators run from the underground metro station till the 3rd floor of Block B and D, ensuring maximum accessibility and connectivity from the street and the metro station into the public functions of the building. This slide zooms into part of Block B, Block F and G. The street leading to the railway station from the main road is lined with commercial activities along a continuous arcade from the main street. The building is scooped out at the street corner, leading to a double-heighted public space for pause and interaction. One can meander from the street through the connecting courtyards into the building and its public functions. The access to the BMC school is from the backside of Block A, ensuring privacy, and yet it is highly accessible with a ramp, elevator and staircase. The courtyard behind the school, tucked away from the bustle of the street, can be used for break times and various activities. Sloping ramps leading to a double-storied underground public parking are in Block G, facilitating a parking-free ground plane. A community hall is located on the ground floor of Block A with spill-out space into the inner courtyard. A private underground car park exclusive to residents and commercial tenants can be accessed from Block A. Private service cores leading to the housing and commercial units on the top floors are located through the basement floors and the ground plane. The first floor of the building complex is an extension of the ground floor with buildings connecting, ensuring free public movement on the ground plane through the double-heighted spaces. The public library in Block E and B can be accessed by the public elevators and escalators as well as the stairs in Block E. The BMC school, the plan to the right, which is in Block F, is housed across 3 floors overlooking the street and the courtyard on the backside. The second floor is inaccessible to the general public, catering to private commercial spaces and workshops. The high sale component of office and retail spaces cater to the floating population at the metro station node, also making the project financially viable, and with the sale of over 50 commercial spaces generating revenue for the project. Private commercial spaces across Block E and G share a connected floor plate. The library continues on to the second floor from the first floor. The fish market plays out in Block D, accessible via the public elevators, which is then cut off from the private commercial spaces with an office lobby space. The third floor is partially publicly accessible with a public thoroughfare connecting the blocks. Here is a zoom in of the same. The skywalk further connects various blocks in the complex, ultimately connecting the fish market to the school, thus creating a thoroughfare 10 meters above the ground. Commercial establishments respond to the public skywalk, building an alternate public interface by increasing interaction between the public and private programs. Private housing makes up the top floors of the building complex, part rehab and part sale. The roof of the bridge connecting Block B and D over the main street becomes a roof garden accessible to the general public, along with the co-working space and the seminar hall. Block A, C, D, and E accommodate housing on its top floors. This is a typical floor plan of the mentioned 4 blocks. This is a typical floor plan with a refuge area in Block E, since it crosses 8 floors. The floor slabs delayered show the majorly public ground plane with commercial activities and service cores leading to the housing, commerce, and the school. The first floor, as mentioned, is an extension of the ground plane's commercial activities. The second floor majorly houses private commercial activities, the school, the second floor of the library, and the fish market. The third floor shows the public walkway starting from the fish market to the school with commercial establishments in Block E. The fourth floor shows the public terrace garden and the co-working spaces, private commercial offices, with the service floors and the housing floors above. This section cuts through the fish market, the bridge, the roof garden on top, the accessible public service course from the metro station up till the 3rd floor of the buildings, the community hall, and housing on the top floors. The section on top cuts through Block B with the escalators and the public library and the co-working space, the courtyard on the street front, and the office spaces in Block B. The elevation drawing at the bottom shows the south elevation of the building complex with the school, public arcade, access to the courtyard, and the public square and the street corner. You can also see the bridge and Block D with the fish market and housing floors in elevation. This section cuts through Block E with the courtyards on both ends, and Block A, B, and the library and elevation. This sectional axonometric view shows the numerous street activities, the connecting bridge, the terrace garden on top, the co-working space, library and the public escalators in Block B, the open street corner on the ground plane of Block D with the fish market and housing on top. Next is a detailed program and area tabulated statement. So basically the gross site area is about 9,000 square meters and the total built up area is close to 30,000 square meters, and hence the FSI consumed is about 3.27. This is a circulation diagram through the building, specifically the first 3 floors and the ground plane, which are quite public in nature. This is a water supply diagram and calculations for the same. There are 3 separate underground tanks, one for Block A, one for Block C and D, one for Block E, F and G. The last one of which is located in the basement of Block E. In addition to the OHDs on the terraces, the service floors will also hold brake pressure tanks. This diagram shows the rainwater collection from the terraces into the filter tanks and the calculations for the same. The use of solar panels to harness electricity and the calculations for the same. Block F is a double-storied public parking space with access ramps from Block G totaling to 182 parking spaces. Block A and E are for private, commercial and residential parking, totaling to 91 car parking spaces. This is a strip section cutting through the car park. Block F, which is the school, the arcade and the shops. This strip section cuts through the steel bridge sitting on I-section beams, the joinery details of the same to the concrete column, and the sectional detail for the terrace garden on top with a 1 meter soil margin, drain board, waterproofing membrane and so on. This strip section cuts through Block C, showing the portal frames framing the double-heighted ground plane, the commercial spaces on top, the service floor and the housing units with terraces above. Exploded axonometric view of Block C and D shows the structural distribution of short span column beam framework of the housing sitting on top of transfer girders, which then distribute the load down to the concrete portal frames on the ground plane. A zoomed in axonometric view of one bay of Block C and D showing further detailed structural distribution with housing and commercial opening details. This is the housing module evolution and typologies. So basically it's two housing units with shared services are placed along a singly loaded corridor, which is then mirrored for 4 housing units along a doubly loaded corridor with 2 service ducts. Then a creation of a service well is done for better natural light and ventilation through the building. A semi-outdoor terrace per housing unit is further introduced, which further reduces the depth of the unit, thus allowing better light and ventilation. The 4-unit cluster is then spaced out to break the doubly loaded corridor for better light and ventilation. And these are the types of housing units with varying sizes following the same diagram. These are the fenestration details for the housing and commercial spaces. For housing, 3 to 4 shuttered full-length windows with a metal railing allows for the maximum opening size and its utility. For office spaces, tilt and turn windows with a metal railing allow much more flexibility and use. All the public programs in the building will have pivoted fins as a facade treatment, which thus can easily be recognized from the street. The fins can be closed and opened by moving the top rail, which is attached to the fins. The fins are made of a saw composite, which is then given a timber finish. And finally, this is the bird's eye view of the entire building complex. So marking the end, I would like to add that with this project, I simply intend to reiterate the fact that a station node involves the need for so much more than the mere building of a metro station as a civic infrastructure. The intricate and elaborate network of human connections cannot be engineered or enforced, but architecture can legitimately design the spatial manifestation of a surrounding that enables such networks to be established and thrive, allowing the public realm to grow. Thank you.